Current cost of the query is 1344, which is unreasonably high. Let me optimize it. Let's check the execution plan once again. You see, we brought cost almost 99.7% down. In this tutorial, you will learn how I managed to optimize this query using indexes. Also, how to read this explain plan, which will help you in optimization. Generating and analyzing execution plan is the first step in the journey of optimization of a query. That is why it is must for you to know how to read and understand it. But first, let's thanks to our sponsor Oracle School. Oracle School offer variety of courses to kickstart your career in IT sector. The data science course by Oracle School will prepare you not only for data science field but also for data analysis profession. Oracle School offered live doubt clarification sessions, real-time hands-on projects, 60+ practice and aptitude tests, and live instructor-led classes on weekends. They also offer 360-degree placement assistance with unlimited job interview opportunities through their dedicated job application portal. They also have flexible payment options. Check out their data science course, link is in the description. Just fill in your details and get a call back. Now, let's get back to our tutorial. An execution plan is a detailed roadmap of how Oracle SQL Optimizer intend to execute a SQL query. It shows how the database will access tables, join tables, and perform operations to retrieve the requested data. I'll show you how to generate an execution plan in a moment, but first, let me explain how to read it. In front of you is the execution plan of a query. The first operation with an ID of 0 is known as the parent operation, which is performed to generate the output. In this case, that operation is a select statement, indicating that we are retrieving data from a table. But which table? You will find out shortly. The remaining two operations with IDs 2 and 3 are called child operations because they exist solely due to the parent operation. The operation with ID 1 indicates that the parent operation accesses a table and that action involves an index. The table name EMP is listed in the second column. When scanning the index, the compiler retrieves row IDs. The keyword by index row ID means that the compiler accessed the table using row ID obtained from the index. The final keyword batch indicates that the compiler grouped those row IDs obtained from the index to reduce I/O operations. Now let's look at the child operation in the third line with ID 2. The type of scanning performed on the index was a range scan. Which index? The one named index_emp_id. This is how we interpret the first and second column. Now let's move to the third column. This column labeled rows shows how many rows have been fetched or affected by the operation. Here it clearly states that only one row was fetched or collected as a result of the operation. The next column, bytes, shows the estimated size of the data in bytes that will be processed or written by each step of the query execution. This value will change according to the filter condition you apply in your query, or if you specify column name instead of using select asterisk. Now we come to the most important column, cost. This column shows a number which is a unitless arbitrary value. It has no specific unit like seconds, liters, miles or kilometer. It's simply a random number assigned by the optimizer to the operations. Remember, the lower this number, the better the query's performance. The higher the number, the worse the query's performance. Our goal is to reduce this number as much as possible. Right next to this number in brackets is another number that shows the percentage of CPU consumed by the operation. In the last column, we have time, which indicates how long the query will take to perform the operations. That's how we read an execution plan. Let's write some queries and see how we can optimize them. You will also learn how to create an execution plan. I have a table named EMP that contains 10 lakh rows. I haven't created any constants or indexes on this table. Let's start with a very simple and popular query, a select asterisk statement, and create an execution plan for it. To create an execution plan in Oracle database, write explain plan for, followed by the query you want to create an execution plan for. In our case, that will be select asterisk from EMP. Once executed, our explain plan will be prepared. To view that plan, we need to write another select statement. Let's execute it. Here is our explain plan. By reading the first three columns, we can easily see that a select operation will be performed on a table named EMP, and the full table will be accessed since there is no index involved. Now let's look at the matrices we need to optimize this query. The rows column shows that 1000k rows will be fetched. To do this, 28 million bytes will be used, which is quite large. The concerning part is that the cost of performing this operation is 1345, which is unreasonably high. We need to optimize this query, and there are several things we can do. First, let's try to reduce the bytes. To start, we will use a where clause to filter our result. Let's check the execution plan. We managed to reduce the bytes from 28 million to 30, which is good. However, as you can see, there is no impact on the cost. Can we reduce it further? Yes, instead of writing select asterisk, let's just select values from the first name column and check the execution plan. Let's check the execution plan. Now the byte size is 13, down from 30, which is positive reduction. We could also consider partitioning the table, but let's save that for another tutorial. Now let's focus on reducing the most important metric, which is the cost. Let's do something about it. The best option here is to create an index on the employee_ID column. Let's do that. Let's execute this. The index is created. Now let's check the explain plan for our last query. Before creating the index, our cost of operation was 1345. Now that we have created the index, let's check the explain plan. Now the cost is 4 and 3 for the index range scan. We have managed to reduce the cost by 99.7, which is a significant improvement. There are still more optimizations we can explore, such as partitioning, but that will be covered in the future tutorial. If you are a data enthusiast aiming to master SQL Windows functions, you don't want to miss my book, Mastering SQL Windows Function. This essential guide is perfect for anyone looking to enhance their SQL skills. It offers clear, easy to follow explanation, subject-wise interview questions from top companies, and practice multiple choice questions to boost your confidence, elevate your SQL expertise, and stand out in your career. Check out the link to my book in the description and pinned comment. That's it for this tutorial. See you soon and thanks for watching. This is Manish from rebellionwriter.com.